Okay, welcome to section 6.1 and 6.2 for Science 24. This is on generating electricity. Science 24. Okay. Okay, so in Alberta, the energy used to light your room at night probably came from potential energy in a lump of coal, right? This is a chemical store of energy stored in a lump of coal. Most energy in Alberta comes from coal burning plants. And energy from burning the coal winds up turning a generator, which in turn produces an electrical current. Okay, so if we've got that here, we've got the chemical store in the coal. It's going to use a mechanical force to turn a generator, which is a kinetic store, which is then going to release an electric current pathway. Right, in this way, the chemical energy store in coal is converted to a kinetic energy store. Now, in the 1800s, it was Michael Faraday who investigated the fields around magnets. And he found that pushing a magnet through a coil of wire generated that electric current. In other words, the kinetic store of energy from that motion generated an electric output or an electric pathway. Now, adding more coils or using a stronger magnet actually produced more electricity. And using these observations allowed him to make the first electric generator. Now, a generator is really just a device that produces electricity. The two main parts are the magnet and the coil of wire. Right? When the moving wire coil through a magnetic field produces the electricity, this works whether it's a magnet or the coil that actually moves. It doesn't matter which one is moving. Right? So you've got your kinetic store of energy caused by the motion between the two, and the output is the electric current. Right? So here's an example. You see we've got motion happening within the magnetic field, and it's generating an electric current. Now, this setup is actually producing an alternating current, and you can see that as the voltmeter is moving back and forth. Here's an example again where you're seeing the current move back and forth with this particular setup, but as this spins, you're generating an electric current. Now you'll notice that the short side here is always pushing current this way when it's facing the south side and pushing current this way when facing the north side. Right? You see it strongest when it's facing the magnetic field, when it's right within line. When it's at the top and bottom, you're seeing the least amount of current. Now, if you use a split ring like this, what you're going to see is the current winds up always moving within one direction. So step one, burning coal converts water into steam. And steam is actually what moves the energy through a turbine to move the generator. And the generator spins, turning the kinetic store into an electric current. So if you take a look, it looks like this. Again, you've got the chemical store using heating pathway, thermal energy stored in steam, mechanical pathway, kinetic energy stored within the turbine, mechanical pathway, kinetic energy stored in the generator, leading to the current. In order to make electricity, we use turbines. Turbines needed to be connected to the generator. They're the blades, right, of steel, designed really to capture the motion so that the magnet can then spin. We don't have it directly. We have a fan or blades, if you will, that actually do that. So electricity generating plants are usually located at great distances from the communities they actually serve. So it often must be transmitted along hundreds of kilometers of power lines, right? And as this happens, as we go from the plant along the power lines to the house, right? Most of the electricity makes it along, about 90% goes along this way, about 10% winds up going to the thermal store of the surroundings. Now, nuclear plants work very similar. Um, they burn coal, often located close to cities, less power lines, but it will also create environmental concerns. In Canada, long transmission lines cause other problems with heavy storms and high winds and lightning and sleet can knock down the power lines, increasing the risk of damage and the time it takes to repair, to locate, etc. So here we see this is from Montreal ice storm. Uh, this is a power line that's been knocked down. You see the tangle of wires around here, and it's a big mess caused by the sleet. Right, another down power pole. In Canada, there's three main ways: the hydroelectric plants, thermoelectric plants, and the thermal nuclear plants. We've already kind of talked about the thermal electric plants, that's the coal burning plants. So we'll also take a look at hydroelectric and thermal nuclear. Now, hydroelectricity is basically using kinetic energy of moving water that's already present. Usually water falling over a dam or a waterfall and turning it into that electric current. You still have the turbine, you still have the generator, you're still taking a kinetic store of energy. Instead of burning coal, however, you already have water that is moving. Right here you can see the water moving, turning this big huge turbine that would turn the generator in the water wheel. You'll see turbines also within the dams in order to capture the water. Right? So water comes in, comes around here to the turbine, which then causes the shaft to turn, causing the generator to turn. Right? Again, you've got a kinetic store of moving water using a mechanical force in order to move the generator, which is another kinetic store that would release an electric current. Now, some advantages are that it's clean and efficient. Once it's built, there's little environmental damage, although the displacement and environmental damages caused by building a dam in terms of flooding everything upstream from it can't be ignored. There are no harmful emissions released to the atmosphere, and these run with extremely little maintenance. They just continue to go. They do require the large dams, which produce large lakes or reservoirs that can flood land and change the ecology of the area, is the thing that we need to be mindful of. So, key points: kinetic energy from falling water. The water turns the generator to make the electricity. Advantages: clean and efficient. The generators run with little maintenance. Advantages: they do require large dams and they require a constant source of water. Right? Running this in Alberta is probably not the best option. We're actually a rather dry province. The Revelstoke Dam in BC, however, blocks the Columbia River. And then here you see these big tubes that can be opened up in order to turn turbines. Now, the coal-fired thermal electric plant, again, is that converting that chemical energy stored in fossil fuels, converted to thermal energy, then to kinetic energy, to electric. We've kind of been through that already. Right, same type of idea as the hydroelectric, except to get the moving water, you burn coal to make steam. Now, it is very expensive to use, and Alberta, as well as other regions of Canada, are very well supplied in this, but you do have to worry about the carbon dioxide for global climate change, the sulfur dioxide for acid precipitation. But honestly, again, the one that I find most convincing is that they are in limited supplies. This is a limited resource. And we use so much of these fossil fuels for the plastics industry. Right, so just in case you missed it, coal, the key point is that you burn coal to make steam, and the steam turns the generator to make the electricity. It's inexpensive and well supplied, but you got the carbon dioxide and the non-renewable resource, and if you wanted to throw a third one, you could throw in acid precipitation or deposition. In a thermal nuclear power plant, again, the idea is essentially the same. It's just, where do you get your moving water from? In a thermal nuclear plant, you have uranium rods inserted to a reactor core to begin the nuclear fission. And the fission produces that thermal energy, where you're going to use that to make the steam, and then everything else is the same as what we've done before. That moving water turns the turbine, which then turns the generator, which makes the electric current. Okay, the turbine, generator, and electric current are the same in all three of these. The big thing is where you're getting that kinetic store of water from, that kinetic store to get the turbines, to go to the generator, to get your electric current. This is really the big question. So the reactors do not release the harmful gases like carbon dioxide and sulfur dioxide. And it's only a small quantity of fuel generates an enormous amount of electricity. The nuclear waste is a concern. It honestly, as we continue to develop and grow this technology, the waste is actually becoming less and less of a concern. And the reason for the storing of the waste becoming less and less of a concern is that we're actually using the waste to generate more heat until you wind up with something that's relatively benign. However, accidents and movies, the fear of nuclear energy and what happens if it goes off is still a very real fear and can cause damage, including plant and animal life. So you split uranium atoms to make thermal energy. The heat, that thermal energy, makes steam to turn the turbine. Reactions do not produce harmful emissions. They generate lots of long-lasting energy. Now, this is considered also a non-renewable resource, but even at current exponential growth, you're looking at, let's say, 50,000 years worth of electricity that's stored within there, and that's including an exponential rate of growth. We still have 50,000 years. There's tons of it. The nuclear waste can be dangerous and the safety can be expensive, is our disadvantages. Now, wind turbines, same idea, it's just that instead of using water, we're using moving air, your kinetic store of energy to move, right? Wind is turning generator and kinetic store is becoming electric energy. There are no harmful emissions and it is renewable, but it is very inconsistent. Okay, that's one thing to watch out for. This is a very inconsistent source of energy. And the danger to flight path and birds, the best place to put the windmills, honestly, is where the birds tend to think is the best place to fly as well. And therefore, the ecological aspects of this can be pretty significant. There's also a third disadvantage here, and that is the pollution in production. Productions. Almost spelled that wrong there. That's a T, not a D. These require many very lightweight, high-strength metals that in order to refine them actually carries a large environmental footprint. Hey, if you do have any questions, please let me know. Otherwise, thanks for watching.